e como foi noticiado também anteriormente. A partir de agora, então, eu passaria então, ao início e o professor Enzo, por favor, pode dar início, então.
Okay, so it's my pleasure to welcome you all in this dissemination event in the scope of FASTEN project, a project supported in the Brazilian side by RNP and in the European side by the European Commission. We are here with an agenda that covers different aspects of the project, and it is with no further ado, I will pass the word to the first presenter. So it's my pleasure to invite Ariane Pereira, our colleague in the project, to say some words to welcome the participants. This is the description of her role. To welcome the participants and present FASTEN concept and organization. So you have 10 minutes. We are a bit delayed, so I will keep your 10 minutes. Ariane, please be my guest.
Okay, thank you, Professor Enzo. I'd like to share my screen with you, and I'd like to make sure that those who are joining us on YouTube can also see. So if someone could give me any information if it's okay on YouTube as well. Do we have a word about that? While we have the confirmation, I would like to thank you, EGOEEP, this event that is hosting us. It's a very good opportunity for FASTEN to broadcast our results in our project. We have here as guests in this session, Cesar Toscano, which is the European coordinator of the project, as this is a Brazilian-European collaboration. And we also have here Wanderson Jesus, which is our project officer from RNP, which is the Rede Nacional de Pesquisa, which is our funding agency in the Brazilian side. And as Professor Enzo told us, we have this schedule for today's meeting. We will try to keep an eye on the track of the time, so I will not further delay presenting this. I believe you have the program at hand. And I would like to present the consortium. FASTEN is a very big project, as it is a multidisciplinary approach to Industry 4.0. So we have as use case two industries that are providing us the drivers, real drivers from real scenarios, which is Embraer and ThyssenKrupp. You will have the presentation of the use case in a few minutes, just following my presentation. And besides these companies, we also have several partners involved in the development of FASTEN project. So you can see here, we have Europeans and Brazilian companies, and we also have research and technology developers involved in this approach, in this project. I will just briefly present the problems that we are addressing on FASTEN. I will not be a spoiler of the following presentations, so just to give you a hint of what is ahead. In terms of the use case of ThyssenKrupp, we are talking mostly about producing parts that will help on the maintenance service. As those who are in industry know how difficult it is to cope with stock levels from obsolete parts, as you need to have a trade-off between the quantity that you are having in store to supply further needs of clients, and also need to have a balance of the amount invested. So if you have a technology that can help you to provide a fast response to the client's needs in terms of replacing parts that need to be replaced in case of an elevator is broken, as we are talking about ThyssenKrupp elevators in this project, then you can have some new opportunities, mostly connecting several technologies. For instance, in FASTEN, we are using 3D printing, an IoT platform that can connect the system, the ERP from the company with the tools that we are developing, and simulation and optimization that can help us to give answers as in which place this part could be produced in a faster way in terms of delivering this to the customer. And in all this process, we have real-time informations. That is a very good thing in these times that we need a fast reply to the client's needs. So in terms of ThyssenKrupp, this is a high-level view of the problem that we are addressing. And you will see in Professor Mauro's presentation a more detailed definition of the problem and also the tools that we are developing for them. In the other use case, which is from Embraer, we have another perspective from Industry 4.0, which is mostly related to the preparation of the pieces, the kits that will go to the production line. And nowadays, this is have a balance between a human and a robotic approach. But as the more we go to the automatization of this task, we have less probabilities of errors in preparing the production line. So this is one part of the problem that we are addressing, aiming at a fully automated material handling tasks. So it's about preparation of the kits that go to the production line, but also in terms of robotic informations. So we are working on several technologies, again, with the IoT platform, simulation and optimization. And the different point from the ThyssenKrupp use case is the robotic picking. And you will see also in detail the problem addressed for Embraer, but also the innovations from these technologies in the following presentations. So this would be all for the moment. If there are questions during today's presentation, I would like to ask you to keep note of them. At the end of today's presentation, we will have a dedicated slot of time to have this debate and also to hear from you who are online watching us. And please so make sure to take note of your doubts, and then we can talk a little bit more about them.
I asked the audience in the YouTube channel to write down the questions in the chat so that I could take note, and then I will make the questions to the speakers.
Okay.
Thank you, Ariel. Okay. It's fine here and in YouTube. I'm following both now.
Okay. So I will try to present here very fast our concepts about work package 5, the ThyssenKrupp case experimentation. The idea is try to talk a little bit about the problem. ThyssenKrupp Elevators Brazil, in Brazil, is split in two main lines: elevators manufacturing and elevator services. When we are talking manufacturing, obviously we are thinking in production plant, production development center, and production engineering. These are the parts of the elevators manufacturing by ThyssenKrupp. And the elevator services, which will be our target here, is split in local service teams, department of service engineering and field engineering. ThyssenKrupp is located in Guaíba, in the south of Brazil, and this is the main plant, I think, in South America. Talking about services, ThyssenKrupp elevator services represent 8% of ThyssenKrupp Brazil revenue. This is one of the important parts of the business, of the ThyssenKrupp business. Preventive maintenance and corrective maintenance is, in general, the concerns of this part of ThyssenKrupp. When we are talking about corrective maintenance, we have triggered a corrective maintenance by preventive maintenance team or by the client using different services offered by ThyssenKrupp. Repair and fix it any eventual problem that might be causing elevator malfunction or lack operation. And based on the network of 61 back offices in different cities of Brazil, and they are 24-hour available for emergency calls and breakdowns. The main problem here, following this structure of the ThyssenKrupp, is identified as the outdated spare parts and high lead time. It is so important to understand how it is possible to work with outdated parts, spare parts for elevators, and how they cause high lead time in this kind of structure services of ThyssenKrupp. Thinking about this situation, we have a FASTEN ThyssenKrupp use case. Here, it is important to present some guiding questions linked to this problem: how to develop or how to deploy a one-of-a-kind manufacturing system for spare parts with sporadic and erratic demand. This is one of the challenges, one of the questions to be answered for the project. How to develop the collaborative robotic capable of identifying and picking parts produced in different additive manufacturing printers. We are working with 3D printers, and I will talk a little bit about these technologies ahead. How to develop an efficient network of manufacturing units capable of providing immediate spare parts availability. This is so important as a question, but it was one of the targets that we have worked a lot on this project. How to integrate a network of decentralized manufacturing units capable of reducing spare parts supply lead time and costs in a big country like Brazil. Additionally, with the technical problems, we have a logistic problem because Brazil is so big, and it is important to think about how this logistic could be made in this territory. How to manage and to monitor the different operations of such network, and finally, how to improve customer perception. It was one of the targets of the ThyssenKrupp in this project, because following the structure that exists today, the perception of these services by customer is so bad. And this topic is really important for the business of the ThyssenKrupp. In terms of park, we are talking about 90,000 equipment over Latin America and 70,000 equipment in Brazil. Problems faced by ThyssenKrupp following this situation and fast solutions. In this case, we are talking in created and developed, demonstrate, validate, and disseminate an integrated and modular structure for the efficient production of customized products. In this situation, we are interested in construct our solution based on these technologies and solutions that we are demonstrate here, based on 3D printers and the mobile manipulator robotics. We have developed a SRun that we will define and talk about this event in several parts of this event. Open industrial IoT platform for customer design products. All this solution is based on this technology, predictive and prescriptive analytic tool, holistic simulator optimizer tool, and real-time monitoring and performance managed tool. These are the basis of the FASTEN solutions for these problems faced by ThyssenKrupp. The idea is to develop a smart robot additive manufacturing units, SRun, that I mentioned before, based on 3D printers, mobile robots, and IoT features, and to provide a flexible production solution for manufacturing companies. The main target here is to reduce logistics costs and production lead time. Adds flexibility and autonomy to the manufacturing unit, improving production scheduling efficiency. The ThyssenKrupp use cases can be or may be summarized in this table. The objective one is to develop this smart robotic additive manufacturing that I have mentioned, composed by 3D printers and robots, aiming to provide flexibility, scalability, and agility to cope with spare parts demand. This consists of scenario one, that we have a smart robotic additive manufacturing unit, and a second objective where we have to develop and demonstrate a set of optimization, simulation, and predictive tools, not only capable of designing an optimal manufacturing network, system configuration, and spare parts production scheduling, but also perform these goals through real-time monitoring system, improving responsiveness and supporting decision-making. This objective consists of the scenario two, smart manufacturing. Will present details about these developments, and they will present some results that we have achieved on this situation. Here, only to demonstrate the technologies, a pilot one that we have developed, here is made by, consists in the use of a 3D printer like this, a robot that supply these 3D printers, and here I have some examples of spare parts that we are producing into this SRun configuration. Talking about SRun configurations, we have designed different SRun configurations. The pilot 2 in the project is located in the lab of PUC. PUC is one of the important partners of the project in Brazil, together with UNESCO Brazil and other universities like Ariane have presented. And we have designed different kinds of configurations like these pictures that we are showing. Other configurations like itinerant smart robotic additive manufacturing are possible to solve the problem of lead time in big cities. We have studied this kind of solution as well and a smart additive manufacturing with a more simple way where we don't have robotic, but we have different 3D printers to produce, and the presence of human research here is important. The other scenario that we have mentioned during this presentation is a smart manufacturing network. My colleagues will present in details this situation, but the idea, the basic idea here is to produce different SRAM units spread in Brazil. We have distribution centers located in different parts of Brazil, and the final customer. This consists in a optimization problem that we have construct modules to solve this kind of problem. In order to illustrate our developments, I have here a demonstration video, and in this case, I will ask for our assistants to pass the demonstration video in order to allow the people from YouTube to see the video.
Okay.
Okay, Ariane?
So, Mauro, I would like to ask you to stop sharing your screen so I can share mine.
Okay. This sound, I think, is a bit low. Maybe I can comment some parts of the video in order to clarify what happened. In this case, a customer have identified spare parts broken and have made a contact with the maintenance team of ThyssenKrupp. The maintenance men have made a request for Guaíba, where ThyssenKrupp have the manufacturing system, and they have started the process to produce the part that they have asked in order to solve the problem by elevator. In this case, the perception of the customer is so bad because the lead time is very high. However, there is a solution, and here the FASTEN technologies have entered to offer another way. And in this case, the FASTEN framework is used by this customer, and the process is the same, requested, and where we have the best SRAM or the most near SRAM available to solve this situation. And in this case, in our example, we have reduced the lead time, and here we have a summary of the solution. using the FASTEN solution, we have reduced not only costs, but the lead time and improve the customer perception. It is possible to identify here in this video the summary of these improvements. The logistic FASTEN optimization have reduced for few kilometers, identifying the best SC run positioned in near from the problem. So unfortunately, the quality of the video was not so good, but the main idea here is try to pass the message that we have developed some technologies in order to improve this kind of problems in industries like ThyssenKrupp, but obviously this is not proper only for elevators. It is possible to apply this kind of technologies for different industries and different situations. One of the main results or the main conclusions that we have find during the project was that this kind of technology could or can improve different productions schemes, and it is so adapted for different production schemes. It is important to highlight this situation because the project obviously have used elevators as in order to demonstrate our pilot. It is possible to apply in other ways, and we are obviously open to talk about that. I think that's it. Enzo, I don't know if I have...
You are ahead of time. Thank you.
Yep.
Yes, you're ahead of time. Maybe you could use this time for some comments, or would you...
Okay. Yes, please.
Okay.
Feel free.
Even though it's not in the questions are planned to the end, since you use your time in a very good way, we can make some comments and we can discuss. One of the things that for me it's so relevant is that the influence of using these technologies, the combination of technologies, not only physical but also logical, and this platform that was developed in the FASTEN project, how this could influence in a positive way for ThyssenKrupp and other companies that face the same challenges, how this could influence strategically. In my point of view, there are two main things. Keep competitive, because serving the client with lower cost and high service level, this is one of the things, but also create new revenue streams. Could you comment on the possibilities of this platform for creating this, keeping competitive, doing what is doing already in a better way, and also creating new business models, new possibilities? We know that today services are increasing the relevance for all economies, including Brazil, and for all companies. Would you be kind
Yes.
to make comment on that?
Yes. Yes, of course. I agree. I totally agree with this vision. And I think one of the important conclusions that we have achieved during the project was that this set of technologies was developed more proper for the suppliers than for ThyssenKrupp. ThyssenKrupp have the opportunity to reduce several services that they have today during the ordinary production, but it is interesting to see that we can promote other connections with ThyssenKrupp. Like, for instance, we have different companies today interested in embrace this service for ThyssenKrupp. It is not conduct for ThyssenKrupp and this kind of technology is mine. No, this is for the market, and we have created one opportunity for the suppliers that we have in the market. I think it is one of the greatest results here, because we are create opportunity for small companies that can produce spare parts for instance, elevators productions or others industries like motors or other parts, other industries. I think it was one of the important conclusions that the project bring to the light.
Yeah, a lot is being said about distributed manufacturing and more integration in this kind of setup. And in this project, it was possible to demonstrate the viability of having this kind of distributed. And then it already influenced positively also other use case. Could you elaborate a bit on that, on this beta issue, or would not be the right time to mention this at least?
No, we need to maturate more details, and after that we can conclude this.
So new things are coming. That's a good message. Also,
exactly.
Possible applications of the platform.
Exactly.
Okay, thank you.
Thank you so much for this opportunity, and I keep my promise.
Yeah, so, in a very good way. Thank you very much.
Thank you.
Thank you. It's my pleasure now to invite Gleverson Lemos to present the other use case of FASTEN project. Use case of Embraer. It is also very interesting, and we are very happy to hear from you, Gleverson, about the Embraer use case. You have, since Mauro was so kind, you have even more than 30 minutes, maybe 35. I can allow you if you need.
Okay, thank you, Professor Enzo.
You're my guest.
It's my pleasure to be here to share our point of view in terms of how FASTEN can be contributing for our advance in terms of technology. Try to share my screen, please.
Yeah, we can see your screen.
Confirm that you can see. Okay, great, yes, great.
Perfect. Thank you.
So it's a pleasure being here, sharing this content with you all. First of all, I'd like to say that not only in terms of technical achievements, technical results that FASTEN is providing for us, but also in other terms of how to collaborate with such important, such partners that could understand our expectation regarding the related technologies, and they could translate it into the best approach and delivering the results that we consider a huge salt in terms of what we are looking forward in the future. So First of all, I'd like to introduce the manufacturing 4.0 Embraer strategy that is considering how we can address all these new technologies involved in Industry 4.0's context, and how we are preparing ourselves in terms of achieving the best use in terms of process and the maturity of these technologies. So the main basis of our strategy is regarding it's regarding three main aspects. So we are looking forward to achieve the best use of digital engineering through some technologies that we consider that can contribute in terms of digital technology. We are looking forward to improve and increase the use of shop floor automation. And in this step, we not consider only robotics, but also all the technologies that are directly applied on the shop floor. And the third part, and the third part of the strategy comprises the manufacturing intelligence, how we can use the data into the best approach, so we can provide the shop floor the condition to decision making. So how to collect data, how to transform data, and how to provide useful information to help the decision makers to have the information on time. So in this context, I can say that FASTEN project address these three main aspects, and have some specific contributions to each one of them. So that's the reason how FASTEN is important for us in terms of maturating some of these technologies according to what we expected internally in our director plan of technologies. Okay. So in terms of structure, Ariane has presented the overview of the ThyssenKrupp and Embraer use case, but it's important to understand that all the technical development provided for our work packages are shared for both use cases. So what I'm going to present you is how Embraer use case address all these technical developments that comprises the use of IoT platform and the applications of holistic simulator, the predictive analytic tools, and the real-time monitoring tool, and also the work package that's related to the robotic manipulation itself. So this is the point of this presentation. Let me just move this. Okay. So the point is that the Embraer challenge for FASTEN is based upon two different scenarios. The first scenario, we can say the adaptive pick-and-place robotic logistics, and the second one is the wing assembly line enhanced decision and management. This is oriented into our shop floor. This is Evora plant that's represented here in this picture, and we have such these two environments that we consider for this project. For this scenario number one, we have here the warehouse where we can store all the parts that are distributed to some specific points in this shop floor. So this is the main distribution point that we receive the components from supply chain and distribute them for some specific parts of this line. Okay, So the first part, the first scenario is related to this this contest, how we can develop a robot that can contribute with the operator to pick the parts that we receive in this system, and to assemble the kit that will be delivered for the assembly line. And the second one is more related to the production line, where we can assemble the wings, and we have a structural process related to drilling, starting fasteners, countersinking, and this is in this case, in this scenario, we are achieving to have a modeling of the wing assembly line, and using some of the predictive tools to preventive maintenance. Okay, this will be further better explained in the next slides. So for scenario number one, what we have is that we have the automated warehouse, and as I said, this is the environment that we store all the parts that will be delivered to the shop floor. And what we expected with FASTEN developments is to develop a robotic solution that is able to pick the parts and assemble this into kits that will be delivered to the production, and providing the online dashboards that can follow all this operation. Okay, this is a quick video that summarizes the main idea, and I'd like to share with you.
Exato alto grau de automação que essa tecnologia traz, a última etapa do processo de separação e kit ainda é muito manual, envolve muito HH e ainda podemos ter falha operacional na montagem e na contagem das peças. Hoje a escala de são 50% da área e a solução que nós implementamos aqui foi a verticalização e a automação. A solução escolhida foi a solução modular. Se trata de um sistema de máquina de alta compactação, onde os sobre as caixas, diferente do método tradicional de automação, que os ossos circulam por dentro do sistema. O desafio do projeto FASTEN é que a nossa variabilidade de peças é muito alta, a quantidade de part numbers é muito alta, uma grande variedade de formas e complexidade de formas diferentes para cada peça, e sim a previsibilidade de peças serão manuseadas a cada momento. Nós temos aqui dentro 18.000 caixas, capacidade para armazenar 100.000 endereços e movimentação de 600 caixas por hora. Aqui nessa instalação, nós teremos 100.000 peças diferentes armazenadas, que atenderá todas as plantas da Embraer. O projeto FASTEN vai permitir o aumento da produtividade dos sistemas por usuários, um dashboard real, permitindo aumentar a produtividade do seu HH envolvido no processo, aumentando a veracidade do estoque, reduzindo a quantidade de tombos do material e permitindo o contínuo desse material até a linha de produção.
Okay. This is the main idea. Is in this, considering the process overview that we have an order received from the SAP, this is delivered to the warehouse, the system that we present to you, the AutoStore solution, that will be delivered to collect the parts from the warehouse. This could be automated considering the auto store or manual. So from this part to the delivery to the assembly line is that the point that FASTEN is actuating, replacing the manual assembly kits by this automated solution based on pick and place robot. Just for you to know, for each box that we have here that the operator receive, this is the possibility of patterns that will store the components. So we have a huge variety of components that is stored into those boxes. And this is one of the main challenges, how we can develop the automated solution able to pick the pieces considering all these different beam patterns. So as you can see, how this is presented to the operator. The operator receive the information through this light that will be put into the spot that the component it is. So the operator pick the component and assemble the kit. And it's the proposal of FASTEN. How to develop the pick and place to automatize this this part of the process. Just for you to know, we are working with different kind of components, but the main parts are such as small components. For example, those presented here, such as fasteners, small parts that will be assembled in the aircraft. Okay. So the second part is related to the scenario number 2, which is related to the wing assembly line for decision and management, considering our structural process. As I said, as I previously said, this structural part it's related to the process that we have some huge automation solutions that it's necessary to perform some operations of drilling, measuring the holes, and installing the fasteners over the holes. We have a couple of these solutions installed in our facilities, not only in Évora plant, but also in Brazil facilities, and the processes are quite the same. So the context here is that we perform the drilling, and also the next operation is regarding the hole measurement, that we use a probe, a measurement probe that will be put into the hole, and it will provide the information if the roll is achieving the quality requirements. So the point is that we have a problem that when we put this probe into the hole, it will be in contact with some oil. So we constantly have to, we need to have the maintenance intervention to assure that this component it's okay, it's good to be used and achieve the good measurements. So that's the point. How we can use this context, this scenario, to develop some predictive analysis to anticipate the intervention of maintenance to not to stop the line to perform the corrective maintenance in that condition. Okay. Similar, I have here a quickly video that summarizes the main idea that I'd like to share with you.
passado por eles futuros, ela está sempre sendo monitorada. Então, nós temos processos de manutenção preventivos, semanais, mensais. Muita semanal a gente faz só a desmontagem de partes, pequenas partes. Na manutenção mensal, a gente faz uma desmontagem completa, mas mesmo assim nós temos ocorrências durante o processo de fabricação. Essas ocorrências, nossa rotina diária, principalmente na produção, todas as máquinas trabalhando. Às vezes pode se deslocar de uma área para outra, dessa forma, a gente atuar preventivamente, preditivamente, de maneira não tão
Okay. Okay. Considering these two scenarios, the technological achievements that is related to the Embraer use case is to deliver the generic solution, adaptable and self-learning, service-oriented architecture, skill-based approach, and for the context of a wing assembly line that involves self-involving real data, support plant management, manage disruption, load balance for new or improved products, and to provide prognosis and prescription in that context. And then FASTEN IoT is the glue, is the solution that will pass through all these scenarios and deliver the results that we expected. So in terms of the way that we work together, the Embraer use case provides some requirements for the other work packages, the technical work packages, the 2, 3, and 4 related to the adaptive pick and place robotics for logistics, and for work packages 3 and 4 regarding the wing assembly line decision management environment. So for each one of that, for example, for the work package that is responsible for develop the robotic manipulation, what we proposed is to develop the different types of end effectors that will be able to be used for the different components that will be providing to that beans, and a robotic arm integrated to and automated guided vehicle able to pick the component and assemble the kits. For the work package 2 that's related to the open industrial IoT platform, the interface with Embraer use case is how we can relate all this scenario in terms of acquiring some data and integrate this with information that is related to our internal systems, such as SAP, the manufacturing execution system, and the logistics system, management system. And regarding the work packages that related to developing the tools, the analytic tools, the expectation is how we can model the manufacturing line, considering the physical assets that we have, and how this can be represented into a simulation line representative for that scenario, that context. For the work package that is related to the predictive and prescriptive analytic tool, is how we can develop this solution, how we can develop the tools that will be able to address the probe measurement probe problem. How we can develop the solutions that can anticipate the scenarios of failing the measurement probe. And for the work package that's related to the real-time monitoring and performance management tool, is how we can provide some relevant KPIs, key performance indicators that we can follow the operation in this scenario, in this context. So in summary, the Embraer use case is the way that we manage all these developments in terms of addressing the real environment, the real Embraer environment, translated into a representative environment that we can check and validate the developments in these terms. So we actuate in terms of the development of these capabilities for the robot as extension of FASTEN platform. We actuate in terms of data collection, aggregation, and process for prediction of robot systems health. And work in order to achieve the ability to integrate the industrial machines and corporative systems data into simulation in other virtual tools to improve industrial management and production line flexibility. In other words, how we can understand the real scenario, the real problems that you have in line, and then checking and validating the opportunity to deploy this development into the shop floor. The demonstrator will be presented the next presentations, but just here to summarize what we achieved up to this point in terms of demonstration. In this picture, we can see the mobile robot at the INESC-Tech laboratory in Évora until on the development. And here, when we could validate this solution at the Évora plant facilities, using this as a representative environment and raising the maturity of this technological into an environment that in the future could be integrated a solution like this. And here for scenario number 2 is the results that we also presented at Évora assembly line, presented some of the indicators in terms of monitoring, simulation, optimization line, considering the tools that were developed in the FASTEN project. And finally, the current status, through this pilot's achievement, we already has a lot of knowledge, a lot of tools, process that now is being available for us, not only in terms of contribution with the science itself, but also having now a huge challenge of how we can address all this knowledge, all this process, all these tools that's developed, and translate it into a maturity technological that we can use them for applying this for the shop floor. This is now what we have in mind from this part of the project for the next months. How we can internally understand what we should do internally in terms of understand our process, understand our systems, and adapt to them to in the future to receive these technologies applied for both contexts. Okay, and that's it. Thank you for this opportunity, and I'm now open. I don't know if I have enough time for questions, but I'm now open for some comments.
Thank you, Gleverson. Indeed, to keep the timing, we could have one question, and we have two. Indeed, I have some questions, but I will convey the questions to the one question from the audience. Seir Medeiros, he asked, how was the cultural evolution and adaptation of employees with these new technologies in regard to the human factor? How they received these new technologies inside Embraer Portugal or Embraer Brazil?
Well, at first, this in terms of human aspects, specifically for this solution, we are still working in a pre-competitive development. So we don't have this installed in the logistic context, but I can say that regarding all the automation solutions that we have deployed in Embraer. This is a change of culture that we put for the operators, that we are avoiding some repetitive activities and put then the responsibility now for conducting the robots, to manipulating the robots. So it's somehow an aspect of evolution in terms of giving them the opportunity to work with a more sophisticated tasks instead of working with manual labor. Okay, this is the culture that we provided considering the automation itself in the past few years in Embraer, changing the repetitive, the manual labor, and translated and putting the same operators with some more sophisticated tasks that is operating the robots.
Well, thank you for it's really, I think, the right thing to do. Take out the operators from the manual and repetitive and train them to perform more added value tasks. Thank you, Gleverson. We will come to we will go for the next presentation, but we will have time in the end for more Q&A, and the audience is invited to write down the questions in the chat in the channel, in the YouTube channel. So later on we'll have opportunities for more discussions. Thank you, Gleverson.
Okay, thank you for the opportunities.
It's my pleasure to invite now Fabio Floriani for starting the next presentation, that is FASTEN, Robot and Additive Manufacturing Integration Systems, focus on practical and technical aspects. It will be performed by Fabio and Rafael, I guess, and also André Scolari. They will share the presentation. So, Fabio, are you there?
I'm here. Can you hear me?
Ok, buongiorno, benvenuto Fabio.
Buongiorno a tutti. Grazie. Thank you.
The floor is yours, Fabio. Be my guest.
Okay. Can you see the screen? My screen?
Yes.
Yes, we can see.
Okay. Well, hello everybody. Fabio Floriani from Consortium Tellimec, Italy. I introduced the robotic part, starting from the of Embraer use case. The first one is to identify inside the bin components that are similar in the same part of the bin. And this is one of the problems. And the other one is to have a methodology that could be industrially viable for Embraer to be applied also in the future. So starting from the first problem, I said that it was related with the fact that inside the bin, different components are the same, and they could be also very small and also symmetric and so on. In order to give to the grasping skill the right position of the object, we can use a classical approach. This classic approach usually try to find a similarity between CAD object and the objects, the point cloud objects inside the scene. But if there are a lot of similar objects inside the scene, it is not so easy for this algorithm to identify a specific object, because as you can see in the picture, different objects could be segmented in the same cluster, or even same object could be segmented into different clusters. So the classic approach are good, they perform well, they have no problem in scenes that are more easy and more classic respect to the one that we had in Embraer. So we use also another approach which is more new, and it is related with machine learning, and specifically with the use of convolutional neural network. This is a new approach to perception, and the idea is to reuse a network that come from big players, for example, Google or Amazon and so on, and to use it also in FASTEN project. But we didn't want to not to use the classic approach, but we want to merge the machine learning approach with the classic approach, because there are pros and cons. Because the machine learning approach requires a huge amount of data to be used, and it is time consuming in terms of computational running, while classic approach are good and easy to implement, and it is also more computationally viable solution. So it is more speed. So we try to merge these two ways. Starting from the scene, we use a convolutional neural network in order to find the right object to be picked. And then we use a classic approach, for example, shift and ransack algorithm, in order to estimate the pose of the object. And then after the pose, we give the position to the grasping skill to be performed. Mainly, and very briefly, we start from the scene. Using a convolutional neural network, we identify the possible objects to be picked. For example, the two that you can see in the first picture. Then we used mainly an approach that it is based in using the depth information from the camera. And so we decided, basing on the depth information, the first, so the object that is more in the top respect the scene, which is the best one to be picked, just using the depth information. And then we give to the other pipeline the best object to be picked. Then the scene is cropped only to the object that it is more suitable for the picking part. And then using the in-stack pipeline, which is based on a classical approach, only to the cropped image, it is possible to use a classical algorithm to have a good pose estimation, as you can see in the picture. So we face the first problem using this hybrid approach, while the other problem, as I said it is that we must have a good solution to be industrially usable in Embraer. And convolutional neural network are a good instrument to be used, and as you see, it is possible to identify a precise object also in complex scene. But the main problem is that to train this kind of algorithm, you need a lot of images. So using only the images without anything else, this requires from an operator of Embraer to make a lot of photos to the same object. For example, different hundreds of photos, and then give this photo to the network. As you can understand, this is not a good solution in industrial terms. Especially in Embraer, because you must put inside the system a new object which could be present in the warehouse, and there are thousands of objects. So every new object using a traditional approach requires to have thousands of photos to train the network. So we face this problem and solve it using a new methodology to train the network, which starts from the CAD model. And the main idea is to generate virtual photo using the CAD model. This is possible by the use of graphical engine like Unity. So we give the CAD model to this kind of tool. This kind of tool generates a different scene, and these different scenes are virtual. And then it is possible to validate this the network that it is trained using this synthetic data, so virtual data. And if the performance are correct, okay, the data set is representative. Otherwise, it is possible to reuse the same engine in order to train again the network using a different data set. Sorry, my dog is barking. This is more or less the way that which the algorithm the CAD approach algorithm is work. It is we start from the CAD model, which is, for example, this multi-side bracket, and we decide which kind of destructor must be used. The destructor are that some objects that are not the same object that we want to identify, but there are different objects that are used only to make a complex, to add the complex to the scene. And then it is possible inside the tool to select different backgrounds. So using this mix, destructors, different backgrounds, we create different images. And of course, these images are synthetic. And some sample images are the one that you can see on the right. And all these kind of images are used inside the network to train the network itself. For example, in a sample case of Embraer, we use 15,000 of images, and it is not difficult to generate such a huge number of images using this approach. Then we validated the algorithm, of course, in a real scene, and we obtain a good result because the accuracy is more than the 90%, which is a very good result using this kind of approach. I can say that apart of Embraer, here in Italy and in Intellimec, we have a lot of interest inside this technology because it is very, very good in industry to be applied. So this is the part of the perception. Sorry if my dog disturb us, but I hope that you were able to understand my discussion.
Don't worry, it was very, very illustrative, very interesting presentation, Fabio. Now I'd like to invite André, not André first, we will have also Rafael Reis making a short presentation as well, and then at the end, André Scolari. Rafael, could you share your screen or how you?
Yes.
Okay.
Yes.
Please.
Hello, everyone. So
remember the time. Remember the time. Thank you.
Absolutely. So Fabio, if you could please unshare so that I can share. Okay, perfect. So let me know, please, if you are able to see my screen.
Yes, we can see it. Go on.
Okay, perfect. So hello, everyone. Again, I'm Rafael Reis. I'm working for Inesctec Portugal, and I will speak to you today about the grasping strategy that we followed on the FASTEN project on both use cases, so on the Brazilian use case in ThyssenKrupp and also in the European one in Embraer, to allow us to have a robot, a mobile manipulator. In fact, it was a collaborative one, being able to successfully pick and place objects either from the 3D printer in the case of the Brazilian use case, or from the automotive, or from, for the automated warehouse in the instance of Embraer. So very succinctly, the grasping planning strategy for the FASTEN project was divided into two different approaches. So the first one is the grasp synthesis approach, and this is an offline training procedure, very similar to what my colleague Fabio described for the visual part, but in this way we will see that this takes into account the three-dimensional information of the objects and of the robot itself. And then finally, on the second part, the online planning part, is the grasping estimation part, which basically takes into account the data set that we have trained before, and during operation, it uses the same data set to perform the operation on the robot itself. So I'll start basically with very briefly explaining the offline part, and then we'll see how the online part capitalizes on this training model. So as I briefly mentioned before, for training our data set, we had to take into consideration the properties of the gripper of the robot. So basically, this is the tool that the robot uses to successfully grasp or pick each of the candidate objects. And for this, we had to map this, this 3D model of the actual physical tool, having into consideration mostly its contact model. So basically, looking into the physical properties of the gripper itself. And on the right side, we see some examples of objects. In this case, in this instance, for the Embraer use case, where we had also the 3D models of the objects, and we took them into consideration. In the approach, I will not get into too much technical details, but basically, it is an iterative algorithm with simulation parts. And it's an optimization algorithm or an optimization heuristic that uses simulated annealing to try to compute which is the best candidate for a given grasping pair. So in other words, it tries to find the best contact point between the gripper and the object, and it does so in an interactive way using simulation. In this slide here, hopefully we will be able to see the videos, but basically it's the software that we developed running. So the first part we generate a very large set of feasible grasping poses. So as we can see, the software is trying to accommodate the position of the gripper with the properties of the object, and trying with this to generate a list of grasping poses which are feasible to achieve. And then on the second part, on the right-hand part, we see the actual validation of these grasping poses, which can be either done manually. And in fact, in the time of the project, we did this mostly manually, but it can also be computed automatically using a machine learning procedure currently. Finally, once we have this offline training pipeline processed, we then basically proceed with the upload of all of these possible ways to grasp the object. We upload this to our digital twin representation, which in the FASTEN project we call the advanced plant model. And this allows all of the robots in the fleet to consult this information in real time. So according to the object that they need to grasp, and also with the hardware they have configured at the spot, at the factory, the robots are capable to consult this model and retrieve the correct information to proceed with the grasping. And this, of course, takes place into the second part of the procedure, which is the online planning, which actually takes place during operation, as I mentioned. And in real time, the robot consults this advanced plant model, which is the digital twin represented here on the left side of the image, that stores this information. And the robot in real time, and this is on the right side is a simulation of that procedure, tries to see which is the best candidate for the configuration and for the morphological location of the object in the scene. Finally, to conclude, this is a representation of how this would look, or how this looks in real time. So there is a sequence of operations where first the components presented by my colleague Fabio before are evaluated. So basically the robot computes first which part is the part that he wants to pick. Then it computes the location of the part. And after that, this grasping estimation skill or capability is executed that allows the robot to successfully grasp this object and also compute the position where it should deploy this object to be shipped for the production part. This pretty much concludes our effort into the grasping part for the FASTEN project.
Thank you, Rafael. Now I pass the word to André Scolari for his talk.
Yes.
Please, André.
Thank you, Enzo. 5 minutes, maybe 3.
Yeah, 3 is good. 5 is good as well.
So, I'll share my screen now. Okay. So, sorry. It's okay?
Yes, we can see your screen. Go on.
Okay, thank you. So, I will present about the algorithms of localization navigation of the mobile platform. So, during the project, you have two approaches to solve the problem of dynamic environments in the shop floors. So the first one is map-based navigation. So in this case, you are using laser scanners, plus odometry, visual sensors, and it's applied to environment where you have a map. So robot estimates its pose, its position orientation using this specific information. Another approach, it's approach using robotic vision. So it's applied to preset paths in the factory floor. So where lanes connect environments and warehouse, for example. In this case, a map is not necessary. So these two approaches, the first one, the map-based navigation, you have used a perfect match algorithm plus a particular swarm optimization, PSO. So it's a precise algorithm based on contour detection. And the PSO, it's to fill the gap of perfect match. For example, for initial poses, estimation of an initial pose, or for the kidnap rob problem. So you can see this simulation, how the algorithms works. And for the path follow navigation, you are using a nonlinear model predictive control. So it's, in this case, you are using a camera to extract and detection the parameters that represent the path to be followed. And you are using the prediction concept to calculate the new reference or the new velocities for the robots. You can see to a pipeline of the extraction of the path to be followed. So it's there is a lot of vision, robotic vision, plus control system algorithms. And finally, I'd like to show you a video where you can see here the Smart Robotic Additive Manufacturing Unit at the Federal University of Bahia. So in this case, the mobile robot is responsible to transport the manufacturing parts to the following stage, for example, assembly or finisher or like that. And in this case, you can see the APM advanced plant model. You can see the map in the localization of the robot. You can see the dashboard with the variables of control and to monitoring some actuator, for example, the gripper. The orders is here. We can see the green lights and the yellow lights here, showing the tasks that the robot must fulfill. So, Enzo, I think that's it about the localization and navigation. Thank you.
Thank you. Congratulations to the three presenters of this part of the project. We will have time for questions at the end. We indeed have some questions from the audience that I'm writing down and I'll make to you. Now it's my pleasure to introduce Mario Dantas, my friend Mario Dantas, which will present the Open Industrial IoT platform of the FASTEN project, the FASTEN Innovations. Please, Mario, the floor is yours.
Thank you very much, Enzo. It's a pleasure to be with you here today. I'm going to share my screen. Let me see here. So I'm representing the work pact 3 that is in charge of the IIoT middleware. This is not the account that...
Okay, you can see your screen.
Thank you. So, are you seeing my screen?
Yes.
Yes. So this work is done by a group that is compounded by Brazilian, of course, Brazilian team and the European team. My name is here because I'm presenting, okay? And I'm going to share to you as fast as I can the experience that we get. So it was very fruitful. You can see the previous one, presenters showing their pictures, and our picture is mainly to receive the data, the raw data from the level 2 that is related for the robotics for both projects, the robotic one and the factory automation, and transform this data and information and provide this as information to the layer above that is the guys involved with optimization. So what the gain for us, I should tell you something very interesting. First of all, is in my point of view as a researcher, as a lecturer, a professor, is that I saw in the floor, the ground floor, the robotics and the factory also knowledge engineering. What's that? Knowledge engineering, you're talking about that 7% of the problems related to the people, 20% of those are related to the process, and 10% is the software. That's what's saw here. I'm going to show you that. We have two main components here. We have the fireware. This is a de facto standard in Europe. And we have also the Apache lane. So both, one is the blue one here, the other one is in red. This is the introduction in the project. And so we work with that we are showing here to provide this IoT, industrial IoT core, to support all the entries that we have the data here through let me call this MQTT Kafka for the software. After this, after the authentication, authorization, data integrity, also working with the data, we have here to deploy the deployment operation that is translated as information, and then afterwards to the work packet that's above of us, the people involved with simulation. Here, we are talking about the Apache lane, the implemented architecture utilizing Apache lane, and here is the slide that shows all the underground floor doing that until you can reach, for instance, we get the data, transforming the data in information, and then afterwards we send this for a database. In this case, a database is in Flux, and to provide acknowledgement that will be seen by the Grafana through a website. Okay, and here the other part of the IoT middleware for this project was the fireware base lane. So we have again we have here the firewalls providing the interface or the IOPC UA agent with the drilling robot interfacing the data that we get there. So through the Orion context broker and the CEP model, we bring these to Quantum Lab, providing these to now information that is going to be stored here in the created DB. Afterwards, transforming this information inside acknowledgement for those who are involved with. It is too much important to say that because, and I was mentioned this knowledge engineer in the first round. By the way, I'm engineering. I have a degree, undergrad degree in electrical engineer and a PhD in computer science. So I was the right analyst guy to understand two different kind of tribbles. One speaking about the robot, speaking about that. The other one taking care of this data to utilize, of course, this in the way to transform it and the information that could be saved and interpret afterwards. Because what I'm trying to joke to kidding with you is that it's too much important. We know this path in terms of the model, the architecture, because we can change the Grafana, we can create and utilize another kind of database, but the idea what we gain as knowledge engineering in the project was very, very nice, very good. Okay, so here you have some pictures of an Embraer scenario where you have the wings assembled and pick up and place things. That's very nice. Somebody asked for, I think for the guy in the Embraer, what they are thinking about that. I can tell you, when we first were there in the Évora, I was very close to the guys there, the workers in the ground floor. They say, what is that? This guy going to do what for us? And one of the guys replied to the other, this is going to help us a lot, provide some checking that is to us is too much tough and something like that. And so this is a secret words that I'm telling you, nobody is hearing that. But in the end of the day, of course, the guy sitting there, get the information, transform this information in acknowledgement that what we have here. I have the acknowledgement what's going on, so we can backwards to to take this the information and then the data, seeing what is going on, and of course fix this path in the backwards. Okay, so here we have the ThyssenKrupp scenario where you have the smart robotic additive manufacture, the SRAM. Okay, when you have the picture here, we have the 3D printer, the UR 5R mixed manipulator, the workstations that you saw here with Andrea showing to us, and here the station. Okay, so you can ask me, so that's good, this is part of some effort from the people from Europe or from Brazil that you saw, but what you have gained also is that. So the next pictures, I'm going to say that what we are developing, also the context-based security. So we're talking about context. When you are talking about context, we are bringing the intelligence for acknowledgement for a more high level that we can understand, and we can provide more security, of course, with that. Okay, so the devices are here, are in the edge tier. So we have the smart device, the robot here. We have the platform, that IoT platform that I'm telling you, where we are studying, we are developing. Of course, the project is going to be finalized now, but the acknowledgement is going on with us, with the pictures that we learn here. Very, very interesting. So we have the authentication of those, we have authorization, utilizing for instance, the IoT gateway. So those two elements are there that I showed to you previously. We are using here the Orion context broker to define one of those. So they have the Kafka connector, also the quantitative here. So inside the platform, so we are putting this out, the data, bring this data, transforming this data information, and storing this data here as information, okay, in IoT data repository, as we mentioned before, in Influx, for instance, and the create DB, or could be MongoDB or PostgreSQL. After that, we can send this to enterprise tier, like a ERP, where we have here the enterprise applications, where the acknowledgement of the information that we have here from the data that we have here can be monitoring, can be provide tools for those in charge of the management of the compound. Okay, so saying that, we are also working with the blockchain. Of course, you have learned about that, about a blockchain security project, to put this, that people here can ask for some robot or another sensor here, and the guy is responsible for that and have the authority to be there. And it's very important to you to think also that we face this due to the pandemic here. The platform tier here that we are considering here, okay, we installed this in one university, and afterwards what we are doing, and actually is already done, we have another clouds that are distributed, that it's very good in this sense for everybody, that we don't have a centralized cloud. And actually it's not what's not the case for testing, but happens. We have one cloud that was enabled to the guys of the project connected here in Brazil, and now they are accessing the another cloud that is part of the compound of distributed cloud. So this is important also to explain to you about the context-based security, and of course the blockchain related to that. Okay, that's our part inside the project. Seems to be very, how can I say, some difficult sometimes, because we are not guys involved with embedded system, but we are involved with how the back end and the front end of the solutions are. So we collect this from the nice pictures that you saw, the films that you saw previous from the work practice, and then afterwards we should send this, as there is a picture here, we are going send this to the guys involved with the optimization. So we suffer pressure from the robot guys. I'll say, we are sending this. And the guys like Enzo, like Simone, wants to do their simulation, so we can do this backwards in the proper way. Okay, and I'm very happy to be part of this group. Of course, as I mentioned before, if you don't know about knowledge management engineer, you should learn about that. It's a very interesting case about that. In the end, I will have some conference about this and that. That's part of the circle of people, and now we are friends. We understand each other like a team that is in the end of the championship. And the process are more mature, and the IoT platform, we are kind to say that we learn a lot. And you must understand that was a kidding before. The IoT platform is discussing around the world, because if you enter, there is an IoT organization trying to standardize all the device that we are utilizing in the industry, in the real industry. Okay, so saying that, I finalize my presentation here. I'd like to thank you for this space here, and I'm open for questions, of course.
Thank you, Mario. We have 4 minutes. I think you can handle this question from Gabriel Bara. He's asking where the dashboard is used. It is in Power BI, we know as a commercial solution, or in another specific software, the dashboard for the KPIs.
Yeah, what we are doing here is providing all the information. We are utilizing Grafana, so you can plug this wherever you want. So it was not specifically, how can I say, assignment for us to use a Power BI or this and that. As you probably saw in our picture, where we have ARP, we have a lot of choice to plug in the solution. So the Grafana one, okay? So it's open. The most difficult thing there, I'm going to tell you, was to marry the 2 different IoT approach that we have. They have the fireware and we have the Apache Lane, and put those 2 things they still work in parallel, but in the end of the day, we collect the data, transforming information for the guy in the dashboard, okay? But it's not difficult to do that, of course not. As soon as we got all the information, bring standardized. Okay, is that?
Okay, thank you, Mario. At the end, we have time for more questions. So it's my pleasure to invite my friend and colleague Simone Arcala and Narciso Caldas from Portugal. Simone is from Goiás and Narciso from Portugal, from Nestec, to present the predictive real-time simulation and optimization. So, be my guest. I think Simone will share the screen, or Narciso?
We'll start, Simone.
Okay. So, ladies first, Simone, the floor is yours.
Okay.
Yes, so...
Can you see my screen?
Yes.
Okay. This presentation will be presented by me, Simone Alcalá, from the University Federal of Goiás and the EGOEEP de Brasil, and also Narciso from Nestec.
Yes, so I think I can start. Can you pass the slides, Simone, please? So this is the agenda for the presentation. First, we'll give you some context about the simulation optimization approach that we do in this FASTEN predictive real-time simulation and optimization. Then we will talk about the design and implementation of it in the project, and we will finish with some presentation about the use cases and application on each one of them. Could you pass, please? Okay, so about our simulation optimization approach. Next slide. In optimization, usually we
can consider some characteristics like stochasticity in the heuristics and meta-heuristics and also in the mathematical models, because it would take a real long time to create these types of models. So in this project, we opt to use a simulation model, which already contains these characteristics like stochasticity, like I said, in its core, to validate the solutions proposed by the optimization model. So we combine both optimization and simulation to have the advantage of both techniques, and we run an optimization model considering all the factor decisions that was built in it, and then we take this solution, which is optimal or near optimal, and we inject it on our simulation model, which contains the main behavior and characteristics of the real system, to calculate the expected key performance indicators of it. You can continue, Simon, thank you.
Okay, and now I will detail the main design and implementation in this model of the project. In this case, we have developed 3 tools for the FASTEN suite, which are able to manage additive manufacturing systems and assembling lines. The first tool, which is called Holistic Simulator Optimizer tool, is able to create and evaluate scenarios, and the real-time monitoring and performance management tool is able to present dashboards and users interfaces, and the predictive and prescriptive analytical tool is able to predict events and prescribe actions. And now I will present the ThyssenKrupp Brazil use case. In this case, we have 3 main functionalities in this use case. The first functionality aims to determine the best place to allocate an order to print a spare part. In this case, the main question is where we should print this order. And the second functionality aims to define the best layout of the supply chain that we call by smart manufacturing network. In this case, we are interested to know how many S1 units should be allocated in Brazil. And the other functionality aims to provide some spare part demand predictions. In the first functionality, we went to determine the best place to print or allocate an order. In this case, we use some optimizations algorithms to do this work. In particular, we use some heuristics with a local optimization, and this optimization algorithm implements an objective function which minimizes the total response time of the order. In this case, the main components in these objective functions are the travel time, the queue time, production time, and setup times. And we also use some forecasting models to determine the production times. This video shows how the software to allocate an order works. In this case, we should create a new stud that we call by operation optimization stud to perform this functionality. The user must select the part to be printed and the number of spare parts, and also the delivery location of the order, that is the customer, the location of the customer. Then the user must save this stud, And the user can execute these stud to run the optimizations algorithms. The user also has access of all studs that are running on background. And
okay, so our big sales pitch.
Implement this optimization algorithm, we use R language and also Google API to determine the travel time. Okay, when the optimizer finishes, the user is notified, and the user can have access of with the information of the best places to print a specific order. In this case, the algorithm has ranked the best 5 places to print a specific order in Brazil. The second functionality, which aims to define the best layout of the supply chain. In this case, we use some algorithms that are the PMedian and optimization algorithm that is called mixed integer linear program models. In this case, the objective function of this model is composed by installation cost, transportation cost, and the production cost. And the main objective is to minimize this function. These images are some screens of the software that is able to determine the best layout of the supply chain. In the first moment, the user must input or create a new stud with some information about the historical of demands of all the supply chain. And also the user must put the number of candidate cities to install the SRun units, and then also with other informations of costs of the supply chain. Then the algorithm in the software outputs a screen with the results, and this screen shows the best place, the best cities to install SRun units. And also the software gives information about how many 3D printers should be allocated in each city. Regarding the other functionality, the main objective is to provide predictions about spare parts demands. So the main objective is to determine how much spare parts will be needed on future. In this case, we use a pool of forecast models. Each one have specific characteristics and have all of them have ability to deal with data and with different characteristics. And this image shows how this functionality works in the FASTEN suite. In this case, for the user has access with demand forecast, it must input some information. For example, the user must input the historical of demands of the spare part that it wants to predict, forecast, and also the strategy of the model selection, if the strategy is automatic or manual. In this case, automatic, the software selects the best forecast model, and if the user select manual option, the user will select the specific models for forecasts. In this form, the user must also input other information. For example, if the predictions are regarding annual demands, monthly demands, weekly or daily demands. And when this form is saved and the algorithms finished, the software outputs this screen that was developed on Grafana with information about the forecasts of a specific spare part, and also with information about the errors of the trained forecast models. Other functionality that we worked on the project is about determine the overall equipment effectiveness of a specific S-run in order to evaluate the real-time performance of the equipment in this S-run. In this case, we have developed this tool, and this image shows a dashboard of this tool. In this case, we have information about the overall equipment effectiveness of this S1, and this information is composed by the efficiency, availability, and quality of the equipment. And also we have some other KPIs of the equipment in the S1. This is all about the ThyssenKrupp use case. Now Narciso will present the Embraer use case.
Yeah, thank you so much. Can you see my screen?
Yes.
It's the slider as a whole, or it's the presenter viewer?
It's the presenter as a viewer. It's not the whole screen.
Okay. Let me disconnect the other screen. Sorry. Now it's done. Okay.
Now it's okay.
Sorry, because this. Okay, so now it's okay. So focusing now on the Embraer use case. This use case was focused on the wing assembly line, where the wings for some airplanes are manufactured, and there were defined three main scenarios for this use case. The first one is called provide best state for maintenance event. The second one provides scenario analysis to support while balancing, and the third one load balance for new product or product change. So looking at the first scenario, looking at the first scenario, the objective of this is to propose the recommended date to schedule a maintenance activity of a robotic resource. In this scenario, we use the three tools of this FASTEN suite: the holistic tool, the monitoring tool, and the predictive tool, to try to predict the failure probability of a robotic resource, and then try to schedule maintenance activity on a pertinent date, so we can reduce the impact on the productivity of the system. So for this, we need data related to the products that are being produced, the operations, the resources and their availability, the production schedule that is currently on the being produced on the system, the work in progress, and of course the maintenance activities data. And next, I have a video showing the demonstration of a demonstration that we did. Sorry. I think it's not running the video. This video is not running. Let me just stop the share screen and try to share it again, but this time with y'all. Okay. Okay, I think I have some problem with the slides. Just a minute, and I will. Okay. Okay, now it's running. So here we have our application on the Embraer use case. This is also a web-based application, like in the Tyson group. Here we are seeing the screen on the predictive and prescriptive analytic tool, where we have the critical alarms being sent through the IoT platform, and the analytic tool is trying to predict the failure probability of a robotic resource. And when a certain level, and when it achieves more than 80% of failure probability, an alarm popped up on the application, as well as an email notification to the pertinent users that should be notified of this imminent failure of a resource. And also the holistic tool starts running automatically. The tool will calculate a series of time slots to execute the maintenance activity, and then simulate each time slot on the simulation model. And in the end, the date with the best productivity will be selected. Here we can see the simulation model. This is running on background when we do a run of the holistic tool, but for presentation purpose, we are showing here because this model has a lot of logic and a lot of the work in it. And as you can see, we have the layout of the system. We have the different types of workstations, the one where the human operators do the tasks, but also the robotic workstations. We have the different type of products, variations of the wings, for example. And also, as I said, the human operators that are working on a wing, on a workstation. So after the holistic tool finish run, a notification on the application is sent, as well as another email notification to the same users to notify them that the results are available. Here inside a run, we can see the results that were obtained, the decisions that were made, also the layout that was tested, and of course we have the key performance indicators obtained by this run of the simulation model with the choices that the optimization did. So the second scenario has the objective to propose the task allocation to workstations and to resources, and also the resource allocation. So this is a decision in the short term. So for example, between shifts. And here we are using the same components as before, less the predictive prescriptive analytical tool. And we are requiring the same data, but less the data related to the maintenance activities. So here, what the tool will do is it will run the holistic tool. The optimization will decide the number of human resources to assign to each workstation, followed by the allocation of each task to each human operator, and then in the end will be decided the task execution sequence. These decisions will be fed in the simulation model, which will run a series of times, and then we'll give the results to the monitoring tool, and they will be listed and accessed on the same pages, like in the previous in the demonstration of the previous scenario. The last one is load balance for new product or change. This is a long-term decision scenario, because here basically we are deciding a new tactical layout. So the objective is to purpose the number of workstations, the number of resources needed, and the task allocation and sequence. Here we'll need data related to the products, operations, the types of resources that will be needed to execute such operations and tasks, and also production forecast. So we know how will be the system will need to perform to achieve the objective of this demand of this forecast. Here we are not using the predictive and prescriptive analytical tool, but we are using the other tools like in the previous scenario. Here we have a diagram of the decisions that are made. So first, the optimization will decide the number of workstations that are necessary. We'll allocate the list of the tasks that need to be executed in the product to the workstations. Then will be decided the number of human resources to each workstation, followed by the allocation of the tasks to the resources, and in the end, will be defined the task's execution sequence. This information will be passed to the simulation model, which will run a series of times, and will send the KPIs to the monitoring tool, where will be accessed in the application. So we conclude here our presentations. Thank you.
Thank you very much, Narciso. We will have times for questions at the end, so that you can keep the time. Indeed, we have questions for you, but we will perform them after the presentation of Ariane. Ariane will talk about the manner by which products from R&D and I reach the market. So it's how innovation occurs and how FASTEN will impact, will provide new products and services to the market. So Ariane, be my guest.
Exactly. Thank you, Professor Enzo. I will share my screen with you. And it's a pleasure to be here again.
Okay, we can see your screen.
Okay. Okay. So at this point of our dissemination workshop, it's a little bit easier to talk about FASTEN innovation, as I believe that now the audience is pretty much aware of what are the tools that we are developing in this project. FASTEN has this name as an acronym for Flexible and Autonomous Manufacturing Systems for Custom Designed Products. So you could see that we have several layers working together to help us accomplish the objective of providing practical innovations to industry and also society. I mean to be theoretical, bringing this illustration here, but it has a purpose to be here. So I will go briefly through this illustration. Emphasize innovation management. We have as fundamental layers the technology management, R&D management, and in this view, we will have several points of control. For instance, when we are talking about fundamental research, we will have theory, applied research, technology, technological development, prototypes, and in product development, invention. But as society and as industry, we look forward actually for innovation. And innovation is when actually our invention has a commercial value and then is introduced to the market. So as in management, have some points of evaluation, this could not be different for technology management and innovation management. So we have TRL. I'm not sure if all of you here are aware about what this is, but this stands for Technologies Readiness Level. So we have from 1 to 9, being 9, what we could say that is something that is already in motion and in operation. as we had a question previously about the human factor, how people would be reacting to the adoption of fasting tools. But as Cleverson answered, fasting is about ITRL 7. So we were working on developing a prototype in terms of a demonstration in operational settings, which were ThyssenKrupp facilities and also Embraer facilities. And these were very helpful things to have in a project. In other words, to have practical drivers providing us the pavements to develop technologies that could actually be applied, and not something that would be some just invention that would not have value to market or society. So saying this, I'd like to address fasting framework. We had here in the previous presentations the views of the innovations in a practical way, but also in a technical perspective. And now I would like to show this illustration that help us to understand that this intention of fasting to provide these custom designed products in a industry 4.0 approach was supported by these three pillars, which were the robot and additive manufacturing systems integration, the IoT platform, which is a central part in technologies for industry 4.0, and also the predictive real-time simulation and optimization that we could see that has in FASTEN different approach from the two use cases, and it's very important in terms of consolidation of we were trying to do. So having this framework, we could see that we have the integration of robotics in additive manufacturing and also using IoT technologies. We could work on improvements for the management perspective, helping on the definition of decision-making and also providing end users with real-time information for two different approaches. In this case, it can be more easily to be seeing this on ThyssenKrupp use case. And we could also work in FASTEN, bringing technologies to help us optimize, synchronize, and also improve real-time coordination of production and also logistics activities. Again, having these two use cases in terms of Embraer, which has one approach, and ThyssenKrupp a very different approach. But in both cases, we could use the same technologies, again, as emphasized by Cleverson, and it was very a good thing to mention that. And finally, we could see that in terms of technologies, these three pillars helped us to improve supply chain performance and also the decision making that we can have when we need to decide about, for instance, additive maintenance. So if in one hand we have this illustration of FASTEN framework, we will see that in the other hand we will have FASTEN impact. And here I like to emphasize once again that in FASTEN we were working, I say we were working because we are almost finishing the project by now, on development of tools that would reach the technology readiness level of 7, which is that a prototype in a environment, in a real setting environment. And from these demonstrations for our evaluation from all the developments that we've been done in FASTEN project, we had a sum of several technologies being developed. And this sum of technologies were answering those drivers from ThyssenKrupp and also Embraer, but they can also be used in an individual perspective. So we are not obliged to use all these technologies just as they were predicted for these two use cases. So this is very important when we are working towards innovation, to have these perspectives for applications of the results. And then in FASTEN, we have several impacts that we can foresee right now, having these two use cases in terms of the intelligent handling of custom objects, very easy to see in both use cases. The full connectivity among all hardware and software components, and this impact in the other slide that we were seeing is helped by several connections that we have made in the development of FASTEN tools. We can also have as impact a better accuracy and also better insights regarding the operation of these two companies, considering that they will adopt FASTEN tools. And also with these developments, we can provide them the means to have a better understanding of the system's behavior, and also some more insights in terms of customization of the parameters that we can implement in the developments that we made. So this is a general perspective in terms of the impact of FASTEN. Sorry, I'm going the wrong direction. And I'd like to say some words about innovation and dissemination. When we talk about innovation, you could see that we are talking about an invention that has a commercial value and has reached the market. And for this invention to reach the market, it has the necessity in terms of an R&D project to be disseminated. And this dissemination will support the further use of these innovations. And this can only be achieved by a collaborative development. In this case, we are working in a two sides project. In one side we have the EU, in the other side we have Brazil cooperation. So it is a both-way collaborations. And then we have the knowledge transfer. You could see that we have several speakers talking here, and we have speakers from Brazil, speakers from the EU. We have speakers that will they work on IoT field, others in simulation and optimization. So in a multidisciplinary project as this one, FASTEN, we had a lot of things happening in terms of knowledge transfer that help us to achieve the results that we are happy to be achieving by now. And when we have these results, we start working on the dissemination. I show here some photos of some events in which we were disseminating, publicizing the results of FASTEN, and this is the basis for further exploitation. In a couple of minutes, I will talk about exploitation, but rest assured that I will not take too much longer in this presentation. And just one coincidence, this photo that you are seeing here, where you have the Embraer logo behind the team, it was taken last year at the same date, the 22nd of October. So it's a very interesting coincidence having these two dissemination events. If it was well planned, I'm not sure that we will manage to have this coincidence. But talking a little bit more about dissemination, to achieve this end, we have a team dedicated in the project. And this team repeats the same pattern of collaboration. We have EU members and also Brazilian members. And we took the care to first look at the protection of the results, because when we are talking about innovation management, besides looking at technology management, we also need to make sure that we are taking the good care of IPR, which is the intellectual property management of the results. Then we have been developing an exploitation plan in which we are thinking about the manners by which these results can reach the market. And the dissemination activities so play a very important role, helping us moving forward with the results of FASTEN, and hopefully working to have these results embedded in new projects and also new initiatives. And I will show this just in 1 minute. But before that, I would like to ask for the audience here, for those of you who are not following yet FASTEN Manufacturing on LinkedIn and also ResearchGate, please do so. Then you can be updated with the latest news about our project, and also with further initiatives that can come after the conclusion of FASTEN. So in terms of FASTEN results sustainability, what this means? It means that when we are working in a research R&D and I project, we hope that all the effort that was taken in the developments can have a longer life, so it can be exploited in further initiatives. And here I bring two examples. In the Brazilian side, we have 2 new projects that make already use of FASTEN developments. So in the 4Fibre is a platform for experimental trials of alarms, considering Industry 4.0 context. And FASTEN Vita was an initiative that we put in motion due to the pandemic of COVID-19. And if you'd like some more information about this, you could follow these 2 links. And I especially call for your attention in terms of FASTEN Vita, which is something that is happening right now, and we need some support. So for those of you who want to be a volunteer or help donating resources, whether it's a material resource or financial, if you could follow this link, I think it would be a very good thing to do. So coming back to the exploitation, besides this further use in research activities, for instance, these 2 projects that I mentioned here as example, they are not the only ones. The EU side also have new perspectives following FASTEN, but we can also think about a more market way of exploiting innovation in terms of developing products and processes. So it could be consultancy services, it can be products, or it can be services reaching the market. And all of this is developed inside the project. So it's very important, because then we can make a very good use of the money invested to finance FASTEN. And you can see here that I put in a light color the use of results in standardization activities, because this is a very promising thing when a project reaches this stage to give content that can be further mentioned as a reference for developments. But that wasn't the case of FASTEN, and this realm wasn't reached by us. However, we have several perspectives of exploitation. And as you could see, we have very good tools that are very promising for Industry 4.0, and we hope that they achieve the market to be applied. So I'm having some trouble passing these slides. This is the last slide, and just to close, the sustainability of FASTEN results, they can be translated in an accelerated adoption of Industry 4.0 tools. And this will be fostered by FASTEN partners. This is part of what we are doing in the exploitation plan. When we are talking about sustainability of our results, we need the engagement of the industry, believing in results, innovative results like this one that we have. So this is one of the reasons of dissemination activities. We can show and we can demonstrate what we have achieved. And another avenue of exploiting FASTEN results that make the project alive is the use of further research. So for those of you who wish to think about a master thesis or a PhD thesis or some more research, we are glad to think that we can have this kind of initiatives inside of the project. I think that would be my contribution by now. And I'm thank you everyone for being in this session with us in FASTEN, and I'm open for questions.
Thank you, Ariane. Thank you, Ariane. We have exactly this right now. We have a Q&A, questions and answers session. I wrote down the questions from the audience, both in YouTube channel and also in the Zoom group. I would like to start with Gleverson from Embraer. We have a question, Gleverson, related to the use of KPIs in Embraer during the project. The performance indicators used at Embraer. The question is from Thiago Otávio. Can you explain which KPIs were used in the project? And if there are any indicators that you did not measure, but you believe would be important? So how you measure the effectiveness of the project and how you, the execution. I think in this direction, he means about the KPIs.
Okay, let me try to comment some words in this sense. In terms of the FASTEN project itself, as I said previously, is a pre-competitive project, so there is no direct KPI involved in this project. But in terms of the two scenarios that we're considering, I can give you as example of some KPIs. For example, for the structural assembly process that it's involved the predictive maintenance, we have some indicators in terms of performance of the robots, in terms of the quantity of holds that the automated solution is able to perform. Also, some KPIs regarding the maintenance as well, in terms of the mean time between failures, the mean time of maintenance. What's the periodicity of maintenance of that component? So we have such a couple of KPIs that we run in the real context. So for FASTEN, we try to bring this as an option for providing this with the tools that were being developed.
Thank you, Gleverson. I think Roberto would like to complement the answer. Roberto, please.
Yes, Professor Enzo and Gleverson, in the ThyssenKrupp case, we are finishing a tool for measuring some KPIs using the approach overall equipment effectiveness, OEE, that is very used in the industrial environments. Maybe I can share my screen quickly. So
you can see.
Can you see? Yeah. Yes, it's not finished in October, and in the next 10 days, we will finish this tool that is under the work package 4. So we can measure efficiency, availability, and quality in production lines. Okay, that's very interesting. It's a new one tool in the final of the project that we saw that is very interesting for industry, and we will present in the next meeting of the project. And Gleverson, if you're free to ask about this in the next workshop, maybe can be used also in the production lines of Embraer. Okay, this is work is not defined since the start of the project. Is after the three years ago we intended to put this and we presented in the last meeting of the FASTEN consortium. But it's interesting tool that use the predictive and prescriptive data to define what is the best SRAM to be a choice by the system to manufacture some pieces. In the case of the ThyssenKrupp is the spare parts. Okay.
Thank you. Thank you.
Thank you for sharing.
Gleverson, taking the opportunity that you are here with the microphone open, I'd like to congratulate Embraer for being a partner in this project. It's really interesting, the scenario 1 in regard to the combination of traditional automation, like the warehouse, which is a very modern warehouse, but it's automated in a very traditional way. We have this structure and have the robots moving above, combined with the flexible automation, flexible robotic approach. This is one case you're having in Embraer. Do you have another cases where you combine traditional automation approaches with flexible automation approaches?
We have around 100 of automated solutions implemented in Embraer. They are mainly focused on structural assembly, similar of those robots that I presented in the scenario number 2. But regarding the nature of the activities that perform in Embraer, we have such a large amount of activities that are manual, especially for those of final assembly. So it's very common we have such in the same process, some parts of them performed by automated solutions, and the other performed with some interface with the human, even manually tasks or using some equipment that can help them to improve their activities.
So thank you. Then it's something relevant for Embraer, and then this combination that we had in scenario 1 regarding the combination of traditional and flexible. Also the second scenario where you have a data-driven maintenance dealing with data collection and then data analysis. Also, this is being used as well in Brazil, or the case is only located in Portugal?
We have the scenario in both sides, in both places, in our units here in Brazil, as well as in Évora plant. And one important aspect regarding that is we find a real problem, a real situation to build the use case, but the results that we expected can be exploitable for other scenarios, other contexts. For example, the pick and place, we are defining this is a logistic scenario, but we have other operations that it's necessary to manipulate such small parts that the same solution could be also applied. As the same point regarding the tools, the predictive tools, we bring this in a context that we have, and we were able to provide a more precise data to define the problem, but the solution itself can be also applied and disseminated to other applications, other contexts that you have in the factory.
Thank you, Gleverson. And now going for the next question, we have a question from Ivan Rodriguez from the audience regarding ThyssenKrupp. I think Mauro will answer it. What kind of spare parts can be supplied via 3D printers? Has the use of conventional machining become or may become unnecessary when using 3D printers? It's a thing related to the machining of these parts. Maybe you have also other candidates for answer. Mauro, could you elaborate on that? How the 3D printing trend will impact in the machining industry and specifically to ThyssenKrupp? Thank you.
Okay, so this is an interesting question. I think I can say some words about that, but the trends of 3D printers today is essentially to work with several different materials. Obviously, here we start working with some plastic pieces, some plastic spare parts, in order to facilitate our work and prove this concept using a pilot. But we have today other types of 3D printers that are capable to use other materials. And for us, this is a plug and play technology to start working in our system. If we have another kind of material, another kind of spare parts, for instance, in aluminum or something like that, it is possible to plug in our system and accomplish this technology in our approach. But I think we have a long way here to improve the 3D printers, but not only improve, to become cheap, to become viable, economic viable to use in this kind of additive manufacturing systems, where we are working with small spare parts, very cheap spare parts. I think this is one important question, and it deserves a consensus or a discussion, a future discussion, I think.
Okay, thank you for your answer. He asked in the direction also if other machining process, other fabrication process will be substituted by 3D print. That's not the case. We have a combination of different processes to handle different geometries and materials and uses and physical requirements. I think this is clear in my point of view.
And I think we have one experience with FASTEN Vita that Ariane have mentioned in her presentation, where we integrate in our systems other types of machines, like
cutting and
different cutting and other types of process, and the system have behaved very well and was adapted for this purpose. For instance, to assist these COVID-19 requirements. So I think we have a very flexible system here to be used.
Okay, thank you. The next question from the audience, it's indeed two questions that at the end converge to the same question. It's for Fábio, Rafael, and André. Caio Barros asked, what happens if we need to introduce a new part into production? Do we need to acquire grasp poses for the new part, or we can generalize for new parts using this technique? And also a complementary question is related, which is the current state of the art in terms of learning on how to manipulate a new part, not previously known by the robot manipulator? how much time and effort one has to invest to have a robot starting to manipulate new physical pieces. This means you have a solution, and this solution is flexible to adapt to new parts coming into production or being handled in logistics. May I ask for Rafael to answer?
Yes, of course.
Please, Rafael, open your camera if you can.
Yeah, so thanks for the question, Caio. It's very interesting. It's in fact one of the topics that we addressed in the final months of the project of FASTEN here in the European part at least. So very specifically to address what was asked, we have looked into how to make the system, make the robot support new parts without the actual need for them to be really taught to the robot explicitly. The way that we are doing this is to have a geometrical approximation to common parts. So for example, if the robot is to pick, for example, a tube part or something that can be approximated to a cylinder, or for example, if the robot needs to pick up something which is a screw or a bolt, so these objects which have a very common representation in industry. The way that we structured our algorithms, not only on the grasping part, but also on the perception part, is to allow the system to support this primitive representation of objects. In this way, we can not only support the robot to pick and, well, operate generally with objects which have a very detailed and present CAD model, but we can also support operation with objects which can be approximated by these geometrical representations. In terms of the time required for testing out or teaching the robot how to operate with these new components, assuming of course that we cannot approximate them with the geometrical objects, I would say that this was also something that we considered in the last review meeting. We have to take into consideration that the strategy that we followed allow us to divide between what is possible to achieve in terms of training in an offline procedure. What I mean by that is the fact that we can have a dedicated personnel or station at the factory responsible for teaching the robot how to not only grasp the object, but also how to see and how to detect this very same object, and then upload this representation or this knowledge to this digital twin representation that we have on the cloud. And this way we can separate the training phase, which is offline traditionally and can take a few minutes or a few hours even, and what is happening on the production line. So I would say that by making this division, the issue of adding new parts to the system can really be focused on the actual pipeline that enterprises already face when actually including a new component to their warehouse systems or inventories generally. And this is something that we looked into the project, and is in fact something that we are planning on expanding on other European projects, specifically one other European project which we have started this month. So yeah.
Okay, thank you, Rafael. This question was about manipulating. I can extend the question now, making the question to Fabio, or it's the same. It applies in the same way for the vision system. A new part coming will be handled, will be recognized also in a flexible way, Fabio.
Yes, can you hear me?
Yeah, we hear you.
So, well, as I said, one of the results of the project is the possibility to insert a new object. I mentioned it during the presentation easily. This is true, but I think that the main obstacle now is regards to the skill, because I think that my question is, are we prepared inside our companies to adapt an artificial intelligence methodology? Because this is I think that this is a common problem for all the enterprises. I know that some big enterprises are trying now to hire people that are skilled in this sense. Because yes, we explained the methodology, which is useful. We can train a new network using simulation and so on. But the network, the neural network must be tuned. So, for example, some hyperparameters must be selected and so on. So the problem is, in a part, okay, we don't have to take a lot of photos, but this is only a little part. We need an expert that is able to fine tune the network, and this kind of resource. Almost here in Italy is not easy to find a skilled person in this sense. But I think if I have a skilled person with this methodology for a new object, maximum 1 day for all. So import the CAD model and select the hyperparameter, and then the computational times depends from the hardware that you have at your disposal. For example, you can think to use cloud services in order to improve the speed. For example, Amazon Cloud, we use this kind of service from Amazon, and so by this way it is easy more. You can train a network more rapidly. But it is not easy to give a unique response due to the fact that depends from the operator, depends from the skill, and so on. So yeah, I think that it is not now a methodology and hardware and software problem, but a skill problem.
Okay, thank you, Fabio. This question also applies to André. If you have a robot that need to move around a warehouse, if you have a new map, how flexible will be the response of this robot to a new map of the warehouse?
So, Enzo, if you have a new map, you are using the algorithm based in map, you need to the robot calculate or map the environment. It takes some minutes, maybe less than minute. It depends of the size of the environment, of course, but it's very fast. And after you do that, it's okay, and you can use the algorithm.
Thank you. Quite flexible. Thank you. So I would like to have a question to Simone and Narciso for both of them, because I saw that in your part of the work, you have a different, a lot of interactions because you have optimization in the European side, you have optimization in the Brazilian side. You had simulation in the European, simulation in the Brazilian side, and you also had used the predictive approaches in both sides. How this exchange of knowledge took place? May I ask that as a question for you?
Yeah, I think I can start to answer, and then Simon could complement. So, because the two use cases have a really different scope. So one is the Embraer is focused on a single manufacturing system, while the ThyssenKrupp one is focused on the supply chain. It's not that really easy to exchange some information or exchange, for example, the simulation or the optimization models, because well, with the optimization more focused on the problem that we are attacking. But we have developed together that architecture that Simon shown, and also the main components. Well, the main characteristics and how we should which application we should which tools we should have. we have the simulation optimization, we have the predictive, we have the real-time monitoring. So we try to follow the same ideas, the same architecture, but in the end we have, well, as you can see on the videos, we have two different platforms because we have two different scopes on the use cases, but the methodologies, the architecture is shared between them.
Thank you.
I don't know if Simon wants to complement something.
Some words on that?
Yes, I agree with Narciso. We have shared the architecture and we have some common softwares, but both use cases have different characteristics. So we needed to develop different optimizations and simulations and predictive algorithms for each use case. So we have double work because we need to study the problems and functionalities with each use case and develop specific algorithms for each of them.
Yeah, I understood that the framework is a joint work and also joint development of knowledge, but then the use cases you have to go more specific in regard to the tools and the methods. Thank you very much. The last question is for Ariane. Ariane, how the project is going now in terms of exploitation? You have several potential tracks or streams for this exploitation. Could you elaborate a bit on that?
Yes, Enzo, for sure. We have a different approach for exploiting FASTEN results. One of them is related to individual initiatives that partners have. For instance, I can bring the example of INESC Brazil. We have contributed in several developments of the project, and we can bring these results to further use in further research projects, but also in consultancy services. This is one example. But we can also think about joint initiatives that work together in Brazilian territory, for instance, INESC Brazil and Bradel. But we also can think about a collaborative joint initiative between INESC Tech and INESC Brazil. So in this case, we have several examples of how we can further use FASTEN results. We have different segmentations. For instance, in Europe, we will have some industrial partners over there and also some commercialization being mostly conducted by some of our partners. And here in Brazil, we will have one company, which is Bradel. So we have several possibilities. This is actually due to the variety of results that we have in FASTEN. We could see throughout the several presentations that we have different approaches, and they can be further exploited in individual perspective, but also combined.
Thank you very much, Ariane. Now I'd like to invite Roberto for the closing, some acknowledgements, invitation to the participants to follow the project. Roberto, the floor is yours. Now I pass the role to you.
Okay.
Close.
Thank you, Enzo. I will quickly end this workshop by thanking all participants and viewers on YouTube. But firstly, I congratulate you, Enzo, for moderating so well this workshop. Definitely, we are in time. So let me share my screen to finish this workshop. So I'm Roberto from Federal University of Goiás, and I am director of INESC PD Brazil, and I'm very happy for this dissemination workshop of FASTEN project. Remember that FASTEN is a research and development project that is supported by the CAL Europe Brazil. That is a joint initiative from Ministry of Science and Technology and Innovation of Brazil and the European Commission. This consortium composed by Brazilian and European institutions work together for reaching new technological solutions under the concept of Industry 4.0. The European team was led by Inestec, whose members belong to countries such as Portugal, Italy, and Germany. And the Brazilian side was led by Inesp de Brazil, that brings together several Brazilian public universities. During 3 years, there was a close collaboration between the participants, mailing for Brazilian side and European side. And fortunately, there was very important results that was achieved, and we can saw these results today in this workshop. The main proposal to the workshop is to present this results exploitation plan of the project FASTEN, and at the same time show technical solutions developed in the FASTEN project. And I'm very glad by the question of the audience, and thank you to all speakers of this workshop, representing the FASTEN consortium, Embraer, ThyssenKrupp, PACE, TXT, Intelimec, Bradel, Inestec, Politécnico de Milano, PUC Rio Grande do Sul, Federal University of Santa Catarina, Federal University of Bahia, Federal University of Goiás, and Inesp PD in Brazil. We thanks to viewers that were welcomed to this session of the Congress of Studies in Production Engineering of State of Goiás, called EGOEEP. The idea of this workshop were to inform the scientific and academic community about the results of the FASTEN project. And we specifically thank to the sponsors that are European Commission and Ministry of Science, Technology and Innovation of Brazil for the valuable intention of finance research, development, and innovation projects. Especially thanks to RNP, Rede Nacional de Pesquisa, for your support to Brazilian side, here represented by our colleague Wanderson Jesus. Would like to thank the companies participating, as we said before, and thanks to ProPartners and Improductiva, the institutions that are managed by students, and make this workshop be fruitful for all people that are assisting this workshop. So the FASTEN Consortium invites everyone to collaborate in exploring the result of FASTEN project, and we are available to discuss with the institutions, universities, companies, and researchers about the FASTEN results. Here we can see the link to the internet site of FASTEN project. So I thank you very much for this workshop, and we prepared to new challenges in the future, I believe. And if someone wants to say some mention to the project, okay, feel free to say something. So if not, we can finish this fruitful workshop for the dissemination cases of the project FASTEN. Okay, thank you very much. Thank you, Enzo. Thank you, everyone.
Thank you all. Thank you.
See you.
Bye-bye.
I like it very much.
Thank you so much. Congratulations.
Oh, thank you.
Thank you. Bye.
Thank you for everyone in YouTube.
Thank you. Thank you so much. Wanderson, thank you.
Thank you. Thank you, everyone.